Good evening, everyone. We are now live in Onshape users worldwide for surfacing in Onshape. Okay, we are live in our Facebook page, in our YouTube channel, and in LinkedIn. Good evening, everyone. Don't forget to register for you to claim or to receive a certificate of event participation and or course completion. Okay, so this session is like an intermediate one. So if you are new in Onshape, please do visit our community where you can find the uh, essential lessons. So let me share the link in the comment section. So please do visit tinyurl.com/onshape users community where you can find the beginner sessions. Okay. We have the uh, sketching and the modeling there. So feel free to visit. Okay, let me post as well the registration form. Okay, and we'll see you after few minutes. Okay, so access Onshape here, tinyurl.com/Onshape users worldwide, and inviting you to join our community in Facebook. We have Onshape users worldwide. We have our Facebook group, and LinkedIn page. So we hope to see you there. Okay, and yeah, in this session we will learn how to make simple and complex surfaces in Onshape with a comprehensive review of surfacing tools and their applications. Okay, so without further ado, I'd like to introduce our instructor this evening. He is an experienced mechanical engineer with a demonstrated history of working in the electric vehicles industry, an Onshape ambassador, and Onshape certified associate. All the way from Kenya, I'd like to add Lewis Maina. Hi, Lewis.
Hi, how are you?
Yeah, all is well. We are
Good.
exciting for this great session.
Yeah, I'm most excited being here, sharing the knowledge. That's very exciting to me.
Yeah, so
Yeah,
let's start.
okay. I want to thank everybody who is present here for the time, an opportunity for me to share what I have. In this world, the learning is never limited. There's always an opportunity to learn and share. And sharing is the most important thing, and the same as learning. Yeah, I have first few slides here. Let me share my screen. Just a minute. Can you see my screen?
Yes.
Welcome everybody to this surfacing in Onshape. It will be amazing presentation I have. I hope you are going to learn something. I will share the link for the model for those who want to practice with me as I model. I will be slow enough for you to follow what I'm doing. And in case you don't understand, just ask. As you have been told, I'm Lewis. I'm a R&D mechanical engineer at Rome. I still am certified by SolidWorks and Onshape. And I'm specialist in CAD/CAM and CAE. Today, my main agenda will be practical. I like less theories. I like more practical. I will discuss surface techniques in Onshape using a hair dryer. That is for the intermediate Onshape users. Some of the surface commands I will use are seen here, but there are so many commands I'm going to use. These are the some. Let's now begin. I'm going to share this for those who don't have. We have the link. For those who have the link, you can maybe open the model if you want to follow as I design. I've already prepared some sketches to save us some little minutes. Let's now start. I have this image. We want to model this hair dryer. As you can see, it's a little bit complex shape surface modeling techniques here. As you can see, we have two sections. We have top section and you have bottom section. Is you have to identify the simplest ways of modeling this model. I like having a bounding surface that is big. You will have a bounding surface. Then from there we start subtracting. I like to subtract what is needed. not needed and add what is needed. For example, we start from top, we model this side section here, we model this cutout, then we model the back cutouts, then we go to the bottom, we model the bottom section that is a little bit simpler than the top. Therefore, I have a main sketch. This is a main sketch that I have modeled on the front plane. Before I proceed, I'm a fan of the shortcuts. I like using shortcuts most of the time. There are so many shortcuts here. I use about 90% of these shortcuts, but for today I will use some shortcuts, maybe 5 or 3. For you to zoom to fit, I'll be using F. Therefore, when you see me zooming the model back and forth, I'll be using F. For the isometric view, I'll be using Shift 7. Make use of these shortcuts, they save you a lot of time. I use almost 90% of this. For the normal view, I'll be using N. I'll be using N for the normal view, Shift 7 isometric, and F for zoom to fit. Only those 3. But practically, you should use almost all of them. They save you a lot of time. For the units, if you go here to this icon here, you can change units, workspace units. I'll be using millimeters in this model. The first thing I said, I'll be using Shift 7 for isometric. First thing I need to do is extrude this surface, the first surface. If you select extrude, in extrude we have either solid or surface. Since we are working with the surface, you select surface. For the sketch, you select your main sketch. This arrow defines direction. If you click on this arrow, you change direction of the extrusion, you change direction. Also, you can use this one here, opposite direction and back and forth. That's how you change direction. I want to extrude towards positive y-axis. You can see from this view cube here, y-axis is towards this direction. And I want to use 100 millimeters. F zoom to fit. F zoom to fit. Then if you want a symmetric model, you can always have symmetric option such that one side positive y-axis becomes 50, negative y-axis becomes 50. But for now, this model is not symmetric along y-axis, is only symmetric along, let me see, it is only symmetric along the right plane. Therefore, if you are modeling a symmetric model, make sure to understand when to use symmetric option and when not to use. For now, no symmetric, then select OK. Make it a habit of renaming your features for ease of troubleshooting and ease of sharing your model, because Onshape has one power, that is collaboration. For ease of collaboration with your departments, your colleagues, or your students, always rename your extrude cuts, your whatever you have created here. Therefore, this one is main surface. Don't rename everything, but just a quick tip, make it a habit of renaming whatever you have created. Then I want to go to right view. As you can see now, this one is the diameter, this diameter, and this diameter here, this height is the same. But from this image, you can see we have some draft. We have a draft here, but our model doesn't have a draft. There's this option that is draft. It is advisable for the plastic components to have a draft. Therefore, I'm going to draft my model, my surface, using 5, 5 degrees. For the neutral plane is where, if I define 5, this 5 is with respect to which plane? In this case, it is a neutral plane. Therefore, if I select front plane, it means from the front plane, the entity to draft, that is my surface. This means from the front plane here, from this front plane, we form 5, from this front plane, there's a 5 degrees value for the draft. Just understand the neutral plane means at this neutral plane, there's no draft. The draft starts from the neutral plane going forward, onwards. But instead of using this 5, I like using variables most of time. Whenever you have a value that you might use several times, always make use of variables here. That is called x. This x here, it's a variable. We have length, angle, number, and any. Mine is angle of 5, so that I can always reuse this variable in my design. Always try to make sure that your design is intelligent enough to save time and enables you for ease of troubleshooting in case there's an error. Therefore, next thing, ours is 5. You give it a name, one name, maybe angle of draft. Then you select it here. You can always give a description here. You can always give a description of what you are creating. It is the angle for drafting surface. Always give a small description so that someone else can understand this variable is for what. Okay, I have already created one variable here, that is draft angle of 5 degrees. Therefore, let me go back to my draft. For the draft, you use that that button. Then you select your draft angle. Then you select the entities to draft my surface. Neutral plane is from front. Okay, neutral plane from front. Entities to draft my surface and draft. You select the variable. As you can see now, you can change direction here downwards. You can hide the sketch. Next thing I need this back surface, like a dome shaped. If you go back to the model, we can use this command that is called fill. You fill surface. Fill surface is used if you want to close one opening, like this. You have this opening. I can just close it like that. But if I select OK, see what happens. My surface is flat, but I need a dome-shaped surface. Therefore, you can edit your fill here. Then, instead of using continuity, we have various types of continuity. Position, this one is a position. I can select tangency. This means that my new surface becomes tangent to this surface. There's a tangency continuity. From this surface, these two surfaces, they merge in a tangency continuity. Therefore, then these two surfaces automatically become merged to one surface. That's the reason why you see we have only one surface, because fill command uses additive, whereby it adds an extra surface to what is already there. Okay, that's the first top section of my hair dryer. I've used extrude, draft, and fill. commands. Next, let's go to the image. Now we need to remove these side cutouts. I said it is a good habit whenever you model a surface. Maybe you want to model in a maybe model. Maybe you want to model a bottle. Always use bigger surface. Then start subtracting what is unnecessary. Therefore, I want now to subtract this section from these two surfaces here. And see, these two surfaces are parallel. Then later we put this cutout. Let me go back. I said initially, whenever you model a model that has symmetry, that is symmetry in nature, always use symmetry when necessary. Instead of modeling this side, then model this side at the same time, I can split this surface to have one half of the surface, then model one side, then use the bigger command to get the other half. Therefore, the next step is we have to split this. We split. We want to cut in two pieces. For the part surface is a part body. Therefore, for the part you select your surface. I want to split this surface. I want to cut in half because if you go front, I want to cut in half here so that I can model one side, then later I can mirror that side to form left side. Let's model right side, then we can get left side later. Therefore, I'm selecting split, split part. You select your surface here, or you can use here. This is the part I want to split. I want to split with what? A plane that passes at the middle, at the center of this model. We have three planes. We have top. Top doesn't pass, you can see. Top sprints, it passes at the center, but these two surfaces, they are not symmetry. They are not symmetrical. You can't use top. If you select front, let's see what happens if I use front. You can see where it is cutting. There's no symmetry. Therefore, I have to use right. The right plane separates my model to left and right, and both are the same. One is mirror of the other. Therefore, I can just select OK. Now we have two surfaces. We have right surface and left surface. Let me add some appearance to this surface. You can see now my model has two surfaces, one for the right, one for the left. I can delete one of them. I don't need both. Therefore, we said a surface is a part body. Therefore, I can use delete part command and select left surface. Just delete it. Delete what you don't what delete what you don't use. Then next, we need now to model these side cutouts. In the surface modeling, always use another surface to make certain cutouts. Maybe you want to create a certain feature that is complex. Use another surface and create that surface. Therefore, in this one, I have this side surface sketch that is I modeled on the front plane again. But you see, whenever I try to edit this surface, my surface disappears. My surface has disappeared. You can see from the parts, you have a zero parts. Why? It is because Onshape, for you to model, always make sure that your features in the feature tree, they follow each other in a systematic way, such that after the delete, I have now to select this one here. You pull it below the delete, so that for you to edit this one, all these features above, they can be available. Because this surface, if you put this above delete, if not try to edit this one, from delete, what is downwards gets ignored. You can see now the delete part comes back because we are using the side surface sketch is on top of delete part. Always make sure you organize your commands or your features in a systematic way. Therefore, let me pull this downward. I'm using this surface because I want to use this sketch, create a surface that intersects with my surface. Then from there, I can split. Let me use my extrude. It is a surface here. I said this arrow for direction. Let me use 100 for now. Then select OK. You can see my surface now doesn't have a draft. I need a draft of 5 to this surface. You select your draft. For the neutral plane, use the front plane. Entities to draft, use your new surface. Draft 1, select the variable here, that is the draft angle. You can see the importance of using variables. You can reuse that variable in your designs a lot. Once I change this value, if I change this value maybe to 10, everything changes to 10. You can see this now becomes more drafted. Both surfaces becomes drafted by 10. Very important to be using variable if for you to automate your designs. You save a lot of time by automation. Then if you go right, this one is drafted by 5. For you to use a split command, always make sure that the two surface bodies, they intersect completely. If I try to split this one, I want to split this inner surface. If you select this part, entity to split with to be this, then keep tool, see what happens. If on, let me hide this. You see now this one here, where they intersect, there's no split. I want a split here on this where they intersect, but if I hide, it didn't intersect here because this model has to intersect my part completely. Let me now delete this. Let me delete my split. I have to elongate this second surface towards y-axis. There are 3 ways of elongating this. First way, I can use extrude. You can elongate this edge towards y-axis. Maybe let me pull, because this distance doesn't matter, provided your surface intersects your model completely. Now my second surface has intersected my model completely, but there's an issue here. You can see now this one has a draft, this doesn't have a draft. I can input a draft to my second surface using front entities to draft this new surface using 5. You have to make sure that these two surfaces are tangent. Now we have tangent continuity, but you see now this one takes more time for me to extrude, draft. That's a lot of time. That's first method. I can delete this. Another method, you can extend this surface. You can use what we call move boundary. The move boundary, you select the edge of the surface you want to extend. The move boundary can extend in both directions. If you want to extend along this direction, Just select your edge and pull, or put value here, maybe 70. I'm using a move boundary. You want to extend your surface so that this surface and this surface here, they intersect completely. That's one method you can use. Assuming you want to make this surface maybe shorter after maybe move boundary, you can always edit and put a new value. Then you can always pull even the other side. The move boundary is both additive and subtractive. You can add the surface body or you can subtract. You can see we are subtracting from the surface. Move boundary is very important tool to use in surface modeling. Okay, therefore let me use 70. That method you can use to extend your surface. You can use what we call ruled surface. For the ruled surface, I want to I want to add another surface to this surface. And there are two ways you can add. You can add normal to the surface. You can see now these two. This surface here, this normal, this perpendicular to my main surface, or you can add tangent. If you select tangent option for the ruled surface, it's similar to the move boundary. They have some similarity, except you can't subtract. If I try to go the other side, it cannot subtract for the ruled surface. You can only add, but functionality is the same as the move boundary, but this one can't subtract. Those are three ways you can use to extend your surface in case you just need to extend. And I said these two, moved boundary, ruled and extrude, both of them can be additive. You can see now we have only one surface after performing these three commands. Therefore, I don't need this one. I can always delete. Then I can always hide your sketch. I need now to split this surface. Why? Because I want to cut this section. I want to delete this section. For me to delete, I need to split this section from my surface one here. Therefore, you select your split. In split, always make sure you understand what you want to eliminate and what you want to retain. In this one, I want to eliminate, to split this surface. What's my tool? What's your entity? My entity is this. Where they intersect, you can see where they intersect. This surface body gets splitted to two surface bodies. You can delete the tool or you can keep the tool maybe to perform another operation. Let me now just delete it. We have now a new surface that is formed after split command and my main surface that is here. Then I can delete this section. I can delete. But now, if you delete, you can see we have an opening that is formed, and I need a surface to replace this opening. Therefore, if I go back to the image, this surface, we want this surface back to our main model. Therefore, I can use my tool, the one I deleted here. Remember, I was using this tool. Okay, sorry for that, not that split 2. Remember, this was my split entity. This was my tool. this surface. I want to keep it to reuse, then delete it after operations. Therefore, let me keep this surface to reuse the surface. This is the surface I need. This is the section I need to replace this opening after deleting my surface that was here. How can I do that? You go back to split. I want to split this main surface such that if I delete this surface, let me cancel first. If I delete this surface, this section to be retained for me to use it. Therefore, I want to split this. What's the motive? What's the reason of splitting this main surface? Because I want this section to be retained. Therefore, I have to use my surface that is touching the main surface. Therefore, you select this surface, but you see you have to keep the tool. This one, I'm going to use it forever, therefore don't delete it. You select OK. After split, the main purpose was to have this section. I don't need this section here. You can always press escape, shift if you want to unselect everything. This is what I need. I don't need this. Delete it. Delete what you don't need. Once you understand what happens when you split back and forth, you will become a very good surface modeler designer, because you have to understand, I want to delete this and I want to retain this. Once you, for example, here, the reason why I'm selecting, let me illustrate again. The reason why I'm selecting this part is because this part has this boundary. You see this one, this inner edges here, this inner edge that intersects, they intersect this surface. Therefore, this will become my tool. This surface becomes my tool to, to cut this surface. Therefore, wherever they intersect here, that's where we get the split. Because this main surface, you can see, this surface, they both intersect. Zoom to fit F. Next step is to model. We have this part, we have this section, the inner surface we have already modeled. Then we have this section here. As you can see, this section is a combination of two features. We have this profile, and we have this surface. This surface is parallel to this. Therefore, if you go back here, I can use offset. I can offset this surface. Whenever you offset, you get two parallel surfaces. You can offset these to 2. That's fine. Then I need that profile here. I do have that profile, side profile. Here it is. I need this profile that I already, let me just pull it down under the offset surface, edit. I designed this one on right plane because I want to extrude this profile towards x-axis. You can see now this one will be towards the x-axis. Therefore, let me extrude this. I want to extrude this side surface. It is a surface. This one, make sure it intersects. It intersects your two surface. You can hide your sketch. Now from here, we need now to perform a couple of splits, and you have to understand what you need, what you don't need. For this one, I need this inner section. This is the contour I'm looking for. I'm looking for this inner contour. I don't need this. For the blue, I need only inner contour. I don't need external. Let's first generate this. You first forgot to split. I need a surface from this offset, and this is the tool because I want the inner contour. Keep tools. I want this inner contour, but don't delete the tool. Keep the tool. Therefore, my offset, remember this blue surface, now it has two. The surface becomes two. We have this surface and we have this surface. You can delete the unwanted section. Delete. Delete what is unwanted. What is wanted, retain. You can see. Next thing is, if you go this side, I don't need this section here. I only need this section. This section has to be replaced by this blue. Therefore, I need to remove this section so that I can see this blue surface. The same case applies. Split this surface. You split. I need to split this using this inner surface. Keep tool. Because why am I using this? I'm using this surface because it is the surface that is intersecting. Surface 3 is intersecting with surface 2. Therefore, if I use this one as my tool, where they intersect, we get a cutout. They split where they intersect. Therefore, we have an inner section and we have outer section. If you delete this outer section, we are going to get an opening. I need to delete this inner section. Delete it. Always split, delete what is unnecessary. Now you can see we have this blue surface that is here. Then this surface, I don't need this intersection here. Therefore, I can always go back to split this one. I want to delete this. You split what you want to delete. My tool, I can use this to be my tool. Keep the tool, split. Therefore, because I'm using this one because they intersect with this surface and this one is unnecessary. Therefore, delete the part. You can see now this one is 2 mm. Remember we used this blue was an offset. This blue was an offset from gray surface by 2 mm. Lastly, this is the section we need. This, you can see this line. We need this section. We don't need this. Same case applies. Split. You want to split what? This surface. Split with, I can use inner. Let me use inner because this edge here belongs to this inner surface. Then keep tool. This is my tool. Don't delete your tool. Then what is unneeded and unnecessary, delete it. Here we are. Now we have my surface, this feature being formed. This one here. You can see now in my path section, my surface section, we have 4 surfaces. We can now combine this one to make one surface. Use Boolean. You select everything, union. You want to unite everything to one surface. Becomes one surface. And now you can use fillet. I want to use a fillet of 6. Fillet this edge. 1. Fillet again. You can always press Shift Enter if you want your feature or your command to be retained. Shift Enter. Okay, fillet this edge. I want to fillet by 1, like that. Fillet again. This bottom edge by 1. Now once my surfaces are now formed, and you are done by this section. Unless there's any question, I can go to the next section that is now putting this cutout. We need, if you select right plane, we need a cutout here. Not a cutout, we need this type of a feature. This one here. We want to use, I'm using right plane because it will be here. Therefore, we need a line. I'm going to use sweep command to sweep. I need my sweep path, a path that is along this surface, a path, and I need a profile that is a circular profile to sweep along. Therefore, the best way to do that is put a line here. Let me sketch a line on right plane, new sketch, a line. You can use any dimensions, but for me, I'll fix this line. Always make sure that your sketch is fully defined. If you don't want to fully define your sketch, use fix your sketches like that. Then I can use a technique whereby if I extrude this line to form a surface body like that, this surface will intersect my surface. And you can say, well, there's this intersection. I need this edge, this curve where they intersect. This is what I need so that I can use this edge to sweep a surface. Therefore, for me now to generate that edge, I can always use split. I'm using this surface as my tool. I don't need it. It is a tool. Therefore, I'm using this. I'm going to use a split. For the part, I said this is what I need to split my tool to be this. I don't need to keep the tool. Don't, because I don't need it. It is just a tool. Now we have an edge that I can select. Then I just need a profile at this point. Then from there I can swipe. Can use sweep command and get a surface. Therefore, this is the reason why I said it's very important to use symmetry, because now my my right plane is exactly at this point, this right plane. Therefore, I can sketch on right plane since this point here lies exactly on my right plane. I can sketch on this right plane, new sketch. I want to use a circle of, make sure that you select this point as your center point of your circle. Then dimension, make use of shortcuts, press D for dimension. Let me use 2.5, like that, select. I'll be using P to show planes and hide. P. You press P on your keyboard. Then I want to sweep. It is a surface. In sweep, you select what you need, a profile, then the path, your edge. Sweep path, your edge, like that. Then select OK. You can see now you have a surface that intersects my surface. Then from here, a simple command, split. You split everything what you don't need, delete, retain what you need. Then if I try to split, I want to split this. Let me first explain. I need this bottom section of this sweep surface. Therefore, I need to delete top section. I need to delete this section and this section. Therefore, I have to use split. But you see now these surfaces, these are two surfaces differently. You can see here we have three surfaces. You can't use this surface alone to split a complete this one is a complete surface that doesn't have any opening. Therefore, I can't use this. If you try to use this surface maybe if you try to use split this, you try to use this one, it can't sprint because you see this one has to completely intersect what you want to split. Always make sure that the tool completely intersects what you need to split. Therefore, there are a couple of ways I can do that, but I will just illustrate only one way. Remember the tool, the surface we used to create this edge on split 8. Okay, let me keep this tool like that. Keep it. I can use this tool to split this shape surface. Then from there, I can use this one to split this. Because if I split this one, let me assign this one a different appearance like that. I can use this one to split this into two half. Then I can use this surface to split this one half. Therefore, you split. I want to split this shape surface. My entity to split with the surface. Now delete the tool. I don't need it. Now you can see we have that half and that half. Now I can easily use this surface as my tool, split this first half using this surface. Keep tool. Okay. I don't need this section here. I can delete it. Okay, delete that section. Delete what you don't need. Then next again, split. I want to split this using this one. Keep tools. Okay. This one don't need it. Delete. I only need this section, but I don't need these two. You can see these two are not needed. Therefore, I can use split again. Split. I want to split this using this one like that. Delete what you don't need. Delete this section. I don't need it. Then split again. I want to split this top surface using the bottom surface. Keep tools. Okay. Delete what you don't need. Let me go back here. I used wrong surface because I used this surface, doesn't intersect this model, delete it, use this. Because this one intersects at this edge, you see. Therefore, I cannot delete it. And my surface is now done. I can now combine this one, using this to this and to this one. You can unite everything now to be one surface. Oh, I forgot to select this section. Okay. Then lastly, make sure you fillet. I want to fillet this edge and this edge. Okay. Go back to my image. We are done by this section. We are done by here. Now it is this back cutouts. This is the last operation on the top section, the back cutouts. Therefore, I have that sketch here. I have a plane. This plane is, I like making sure that my sketches are always outside the model. Let me just pull down this to the edge, to the edge. I used knowledge undo. I need this one here. I need to pull this to the end. There's a problem here. Let me see. There's a discussion here. A missing selection. Let's edit. Missing part 12. We have this surface here. Therefore, let me go back to Boolean 2 to fix this issue. I have to select this surface. Select this and this. Okay. Just, I think there's an issue here. Can try to fix it later. Then I was saying now we need this back cutouts here. So this sketch that is already designed on a plane that is back cutout plane that is that I used this back cutout plane. Let me back cutout plane. This plane is an offset from front plane. You can sketch these sketches on front plane, no worries, can do that. But personally, I like having sketches outside the model. You can still have these sketches inside the model. Okay. Then I need now to split. I want to split this surface using the sketch so that I can delete those faces. Therefore, you go to split. In this case, you select the face. I want to split this face using the sketch here, my back cutout sketch. Then you can hide your sketch here. I've used my sketch to split my face. You can use your a surface to split another surface, and you can use a sketch to split a face. Therefore, then I can easily select this new face formed and delete them. I'm deleting a face because this one is a face, not a part. You can see here we have three surfaces: this surface, this surface, and this surface. If you after Boolean, it will form one surface. Therefore, I have to delete this surface, this face, and this one. You delete a face like that. Delete. Then lastly, you can use now, you can mirror. I want to use, remember the plane we used? We used the front, the symmetry was right. We have entities, my mirror plane was right. Entities was, I want to mirror these entities. I want to add all of them. Merge with all to form one surface. Now we are done with our top section. That was a little bit complex, but the bottom section is the simplest. And we have used a couple of surface tools. We have used, let me check what we have not used. we have used all of them to illustrate how to model this section. In next section, I'm going to use just loft, the one we have not used. We have not used a revolve, but now let's use loft. For the loft, we need now to model this bottom section. We're going to model, have a bottom, a top sketch, bottom sketch, then loft. Let me use the model that is already available to just illustrate quickly. We have top section. We have a bottom profile here. That is, if you hide, let me hide my, we have this bottom profile that is some distance away from the top plane. We have a plane here. This plane, the difference between these two planes determines your height. Therefore, you can create a plane at certain height so that you can sketch your bottom profile. Then you have a top profile. This is a top profile. Then we have front profile. Our hand will have this type of a shape, and make sure that this profile and this sketch they meet. They are they are coincident, or they pierce exactly. They have to pierce for this function to work. Same case applies to the back profile. This back profile defines the back shape. This back shape here is for the back profile. Then you loft this to this. Let me illustrate how you can loft. You select the, let me hide this. Select the loft. In loft, in loft you can use solid or surface. For the profile, I need bottom profile to top profile. See what happens. Then for me to have this type of a contour, you select what we call guide. For the guide, you select the back sketch. This one is an arc and a front arc, just like that. This one forms the bottom section of the hair dryer. Then we need to have some fill surface here. And I said, if you select the fill command and select this edge, it forms a flat surface. If you select tangency, let's see what happens. That doesn't function. If you select OK, this becomes flat, you can see. And we need to have this type of a shape, dome, a small dome shape, a very small one, you can see. Therefore, you need to use what we call a point. I can have a point on a plane. That is, I can have a plane here. Let me offset a small plane. Maybe I want to have a point at 15 away. I want a point on this sketch. Therefore, I need just one point. Like that, you can fully define the point. Shift 7 for isometric. The point that is 15 mm away from this bottom edge, 15 millimeters on this plane. I want this fill pattern to use this point as the guide, to be the guide of the surface. Therefore, if I try to edit, you can see everything that is below the fill is not is is not activated. You have now to make sure that your sketch, what you want to use, go above the fill command. Even if you do that, this sketch uses the plane, therefore you have to make sure they follow each other like that. Now it is okay. Now I can use edit. Now I can use my guide. I can use my point like that. And my dome shape is formed. Then you can fillet this edge. If I show the sketch here, I want to show the main. Now they are, let me hide the new one. I don't need it, I was just using it to illustrate. Okay, then you can, let me hide this, let me hide the sketch. We need to hide the sketch. Okay. Then after that, then we need to perform this cutout, this section here. The similar approach to what I did here. That is, we have the bottom surface. That is after that. Let me go back here, roll to here. You can see, as I illustrated, these two surfaces, they intersect after loft feature, they intersect. And you can use the split to separate these two. You use the split command here, split 15 up to this point, so that you can delete what is not needed. And let me go to this point. Yeah, let me go back to this point right here. For me to make this cutout, what I did, I used an offset surface. You offset this surface. Let me show the image. This cutout. Remember this inner surface here and this main surface. They are parallel. Therefore, you offset this surface inside. You can see we have this surface that is an offset by 4 mm. Then from there, you have my cutout sketch. Let me roll to here. You have these two sketches here that you can use to split. You can use to split this. Therefore, if you select split, make sure now this is the last command for the split. Make sure that if I want to split this outer surface, because I said we have two surfaces, we have this outer surface and the inner surface, the orange one. Therefore, you select the face, you select this outer face. For the entity, this sketch. But you see, if you select one edge, becomes difficult. Therefore, you have to right click, you create selection. You click here, you create selection. It is an edge. I want to use this one edge that is connected. Add selection. You see, okay. Now this outer surface has a split. Then this one you can delete it because you don't need it. When you delete, you leave open because there are three ways you can either heal, cap, or leave open. Leave open because you don't need it. Then you split the inner surface using this sketch. Again, split a face. You select a face, select the inner surface, right click here. You right click, selection, create selection, edges. You select the inner sketch, add selection. Okay. Then for this one, we don't need this side. You delete it. Delete a face like that. Leave open. Then we can use loft. You can loft this edge. If you select a loft one for the profile, let me use, let me just create this edge. You select this arrow, you select inside, then you select all edges, or you can use create selection. You can use create selection or select one by one. You have to make sure that the profile is continuous. The- I've used for selection because I have selected this this bottom curve, top, this line and this line. Then we need to loft with another profile, that is this side. If you continue selecting, you get an error. Don't continue selecting. You see, just delete this one. You select inside here. You add, you add edges here like that. F to fit like that. Okay, that's how you form this back cutout here. Lastly, this is the last I'm illustrating, is how to form this neck. You can see we have a smooth transition on the neck. Therefore, we need a sketch for the neck. I think I have a sketch for the neck. Neck sketch is here. Let me show. I have a neck sketch. I want to use, let me quickly convert entities. Let me quickly sketch one on the front. Go to front, new sketch. You can press N for normal. Sorry, I'm using right plane, not front. Yeah, right plane here. You can quickly sketch an ellipse on the right plane. Ellipse. This one seems not function. Okay. Okay. Let me show the right plane. New sketch. I need ellipse. Oh, seems not to function. Don't know why. Okay, let me use the existing one here. I have a next sketch. Let me start this. Like my internet is a little bit slow. Basically, okay, okay, here. Let me not try to sketch again. I need new sketch on right plane. Then I need to select ellipse. I don't know what's happening with my tools. Basically, what I want to illustrate is you can create this shape. I want to create this shape now using an ellipse. Then you just use split command. You delete the inner surface. After using assume you have a split ellipse surface here. You extrude until it intersects the top section and the bottom section. You delete the middle surface face. Then you use loft command to combine these two. Yeah, and I think I'm done. I think my internet is a little bit slow, but I think I'm done. Yeah. Any question? I'm ready to answer.
Okay. Yeah, if you have questions, feel free to post it in our comment section. So here from Arkal, can we use fill with continuity position after split 2?
After split 2, let me go back to split 2. This my, like, let me go back there. Let me roll to here. You can roll back to where? Or then let me suppress. Okay, roll to here. He's asking whether we can use split 2. Let me hide this surface and hide this. Not that. He's asking whether we can use fill command to fill this opening. It is possible to use, but now you need some guide curve that follows. If you use the fill right now, let me select the fill to show this practically. That edge, that edge. See what's happening? Okay. Let me try again. This edge and that edge. It draws some errors. I think this is a little bit tricky to use. Basically, what I want to explain is sometimes you can use fill command, fill tool, but you have to create a curve that follows this shape. You need an extra geometry to be your guide, because you say the fill command makes sure that these surfaces it forms a straight surface, flat surfaces. But for you to have a curve, you need a guide and you need an extra curve. You can see vertices or curve. Yeah, it is possible to use fill, but you need an extra curve that is a little bit complex, but that's possible.
Okay, so yeah, so if you have any more questions, feel free to post it in our comment section. So while we are waiting for your questions, I'll be playing a short video.
Yeah, I can still motivate you guys to work on the.
It used to be that you would design under one roof and then manufacture under one roof. What we've seen is a lot more specialization. Expertise has become fragmented, and as a result, each of these people need to coordinate and work together in the design process. They can be across the state, across the country, across the globe. And so people need tools to be able to interact and communicate. We took the opportunity to look at how the CAD world had evolved, how product design had evolved, and how the computing infrastructure had evolved. And we decided to hit the reset button on product design software.
Onshape is building a new generation of CAD, one that's designed for teams to use. Everyone on the team can use it anywhere, on any device, anytime.
We're capitalizing on the platform, the cloud, mobility, and redesigning essentially what CAD is to help people design products faster, easier, and more affordable.
20 years ago, when we built SolidWorks, we built CAD on the modern computing platform, the Windows PC. It runs only on that computer. When it comes time to work as a team, users have to use all these schemes to copy files, check in, check out. It's kind of a hassle and it costs them time. Today, CAD still runs on that Windows PC, but people are used to using their phone, their tablet. People are used to working on multiple computers and going into a web browser.
Teams are built up and torn down quicker. There's a lot more collaboration, tends to be a lot more contractors, a lot more consultants.
And so the rest of the computing world has changed a lot, but CAD hasn't. And it's time for CAD to evolve.
You know, users, they're like all of us. They're tired of trying to figure out what's the login password for the data vault, because I don't use it all the time. And when I get the assembly, all the links are broken.
License fees, installations, license managers.
Do I have the right version of the part or the right version of the assembly?
I visit CAD users. Years ago, I'd talk to them about modeling cool shapes and cool products. But in recent years, when I visit users, they're talking about all the hassles of CAD. And it's time to get rid of all that.
Users today expect that we should just be able to access information and share and work with other people real time, much like the way that Google does for working on a Word document. We've done that for the CAD world.
We get to collaborate on the same geometry, which was never done before. We have found ways to break down our modeling paradigms, our assemblies, our models, our features, so that multiple engineers can collaborate on the same feature, which was never done in CAD before.
The cloud is really a transformational platform.
We put the CAD system and the CAD data in one place in the cloud, and one master copy of the CAD data that everyone can access simultaneously from anywhere through any device. So there's never any copying of a CAD system, and there's never any copying of CAD data.
When we're working on something simultaneously, you see visual cues to understand what part of the model you're working on, what part of the model I'm working on.
Even people who see Onshape once will say to me, "Hey John, can I get a copy of Onshape?" And I say, there is no copy of Onshape. I don't have to send you a copy. You can log in from any computer. You log in through any web browser and you have access to the whole system. Even if you have an iPad or a phone, you can use Onshape.
It can be used by the single user working at home, the small design professionals, small teams, through to some of the largest manufacturers in the world.
CAD users, product designers, engineers, they don't sit at their desk all day. They're in meetings, they're moving around, they're at the coffee shop, they're having lunch, they're home thinking about it on the weekends. Wherever they are, whenever inspiration strikes, they should have access to CAD, and with Onshape they do.
Browser technologies, mobile technologies, and cloud technologies are converging and giving the capabilities to build complex system like ours.
What we are doing here is very forward-thinking and innovative, and we have the team that can achieve this.
We've got people who are the most experienced, talented, smartest software engineers and CAD engineers that I've met in my career.
And so it's serious CAD, it's serious design software.
You get products done faster by teams, and you'll get them done better because they have more time to spend on engineering. And finally, I think engineers and designers will have more fun. You know, Onshape's just more fun to design with.
Okay. So do you have a sample automotive surfacing works you can show to the audience?
Yeah, I have few examples I did. Where I work, we design these products with this electric bike. We designed this bike from scratch using Onshape, and it has really helped us for collaboration. This is a bike we designed in Onshape from scratch, and we will design several engineers, and we collaborate a lot using Onshape, very powerful tool. This is another off-road vehicle. We designed only the drivetrain, this electric vehicle. We don't design the body. All these parts we designed using Onshape, all these ones. Then for the solar compartments, all these boxes here, we design them using Onshape. Therefore, Onshape is a tool that is used widely by professionals to collaborate and for ease of designing. I think I have this one is a helmet. My internet has some issues. This is a color battery for the surface modeling. If you want to just make simple designable designs for the with surfaces, this is what I do whenever I get my own time, just to play with on-shape surfaces and make simple designs like a shoe. This one is a shoe, a simple shoe. I have a simple mouse, a helmet. Yeah, there are so many things you can do with Onshape. This one is a battery. Yeah, I use Onshape as sometimes as a hobby when I have some on my own time. And model products then there, here and there. Yeah.
Okay. So, may we ask, how did you discover the Onshape and what enticed you to use the software?
That's a good question. For the previously, we had some problems when we wanted to have collaboration, files, and data management. Then that was time of Corona, whereby people are working from home, different projects. It was so hectic. Then we decided to switch to Onshape because of the collaboration. We could design a model. We could collaborate on one design, about 5 engineers on one design at a time. Then the data management, versioning, amazing. Then I came to hear about Onshape on LinkedIn. Personally, I'm very active in LinkedIn. Then one day I saw some presentation of someone illustrating how to use a cloud-based software. He was using Onshape. I was I got excited from that day. Then from there we started venturing to the Onshape. Yeah, you can see this my mouse, the one I'm using. I designed in Onshape.
Oh, that's awesome.
Yeah,
Okay, so next question. Can you share to us what it is like in Kenya as a mechanical engineer?
yeah. It has been my passion from high school to become a mechanical engineer. Because mechanical engineer is I like mechanical engineer because you create something and you see it functioning. Like programmers, they don't know what's happening behind the screen. But for the mechanical engineers, you do something, you design, you manufacture using CAD tool. In Kenya, we have a lot of engineering work. We have a lot of engineering problems we solve. Like for example, you are solving some engineering problems for the environment where I work. We work with electric vehicles, whereby we modify the combustion vehicles to electric. That's one thing we do in Kenya. Then in manufacturing is one of the key area that is given high priority by our government. Therefore, I can say mechanical engineering in Kenya is it's good.
Okay, so yeah, what inspired you to become a mechanical engineer? So I think medyo you answer it
Oh,
a
I,
little
I
bit.
I think what inspired me most is to see things. Mechanical engineers is where you create things that machines. I used to become very impressed to see how machines are functioning. Whenever I go to an industry, I see a machine, a robotic machine. Then I got excited. I have to know what's happening here. That's from that time when I was in high school. I got that mentality. Let me venture more in engineering to solve such problems, excavators, big machines. It was just an amazing. I was just a little child when I saw those stuffs. I remember my first time I saw a CNC milling machine. I was around 12 years. I was it was amazing to see a machine cutting a metal. That thing just busted my mind. What's this? Then I said, I have to venture in mechanical engineering to design those big machines. Yeah.
Okay, yeah. Yeah, aside from AutoCAD, what CAD softwares are typically taught in Kenya?
When I was in college, we used to learn SolidWorks in our school. There's another university that used to teach inventors. Basically, there are not many that are taught in Kenya, but Invent and AutoCAD, SolidWorks are mostly taught in Kenya. Then Onshape is now putting the roots in Kenya. But those are the main. SolidWorks, Inventor, those are the main that get. And some architecture cards that are usually taught in Kenya. Who want to become a teacher?
Yeah. Yeah. Aside from Kenya, what neighboring countries in Africa are growing rapidly fast with technology?
We have this South Africa that is growing very fast. We have some countries like Egypt. We have a couple of countries. Yeah, but Kenya number one.
Okay. So,
Yeah.
yeah. Who are your top three idols in tech?
Top three. Top three thoughts.
Idols in technologies.
Don't I don't understand that question. Can you paraphrase maybe?
Eh, Yeah, the one you look up to.
The one I look up to, my mentor, or okay, that's a tough one. Uh, I have a couple of in Kenya. We have these bodies. We have engineers board of Kenya in our country, whereby engineers they have a board whereby they meet all the young engineers. They usually mentor us, and from there, each young engineer is assigned one experienced engineer to be a mentor. We have that program in Kenya, but most of the time I always compete with myself. Most of the time, I always try my best level to go beyond my limit.
Okay, so yeah, I think for the last question, so any message or thoughts for those who are studying mechanical engineering or planning to study mechanical engineering, can you give them a short message or inspiration message?
I I think as a mechanical engineer when I was in college, one thing that drove me was passion. I had a lot of passion for the engineering. That is mechanical engineering, and that that personal drive, that passion, made me go extra mile. And for you to become a good mechanical engineer, you have to always sacrifice a lot of stuffs. For example, most of time, whenever others were watching movies, I was investing in card cam. Therefore, I want to know you have to understand that mechanical engineering is not about maybe performing well in your grades, getting an A here and there. It's about skill. You have to gather more skills as possible as you can. Go to the card industry, make sure you know some skill. Go to the computer aided manufacturing, get something. Go to the computer aided engineering for the finite element analysis, get something there. Equip yourself with so many tools You keep tools fast, practical fast. Don't have a, for me, I used to hate theory so much personally. Theory was not my friend. But practical stuffs, I used to have a lot of tools on hand. Make sure you are prepared with these tools, sharpen your tools with a passion, okay? And teach others. The more you teach, the more you become better. If you know you're good in, if you know you are good in maybe AutoCAD, go to your go to your teacher, get 5 students, teach them free, share the knowledge. You become better in that. Right now, the way I have shared my knowledge on the Onshape, I have become better today than the way I was yesterday. Yeah, yeah.
Okay, yeah. Yeah, you got a message from Mark. Yeah, thank you so much. We hope you visit Philippines in the near future and us visiting Kenya too.
Yeah, thank you too.
Okay, yeah, thank you very much for doing this for our community. And yeah, we'd like to award this certificate of appreciation to
Ah,
Lewis Maina for sharing his valuable knowledge as a sharer in surfacing in Onshape, held on 21st of May 2022, live streamed from Metro Manila, Philippines. Signed by our event chairman, Jomar E. Bakiran. Thank you so much, Lewis.
thank you so much.
Okay, so yeah, that concludes our webinar this evening. So if you want to watch again, so the replay is available in our community. We'll be pasting the link. Okay, so inviting you to like and follow Onshape users worldwide in Facebook and in LinkedIn for more Onshape webinars and trainings. And we hope to see you again. And yeah, Lewis teaching us once more. Okay, so yeah, thanks everyone. Have a wonderful evening. Bye.
Onshape is the only product design platform built from scratch using the latest cloud, web, and mobile technologies to complement the way today's professional design teams really work. With Onshape's unique database architecture, you can build complex parametric parts, assemblies, and production-ready drawings together as a team. Unlike old CAD, data management is built in, so there's no waiting for files to be checked in or checked out, no accidental overwrites, and no expensive PDM software. You can explore new concepts, new ideas, and new design scenarios simultaneously within the same document, merge changes together, and browse every design change ever made, so your entire team can design with confidence. Sharing design data with your team, your suppliers, and even your customers is easy. Simply enter their email address, assign access rights, and click Share. Clicking the link in the email opens your document in a browser or the Onshape mobile app for instant editing or viewing. Sending CAD files in unsecure email attachments is now a thing of the past. For the first time in the history of CAD, teams can work together on the same assembly, same part, even the same sketch for true real-time collaboration. As team members edit or create new features, updates are reflected everywhere, within seconds, so the entire team can see the impact of a design change instantly. With simultaneous access to the same CAD data, design workloads can be shared easily. Every team member, partner, or supplier can contribute in real time with no restrictions, enabling projects to be completed in record time while maintaining full control over your company's intellectual property. Whether your team is located in the same office or across several time zones, Onshape's powerful collaboration tools inspire teamwork and boost your productivity. Teams work better in Onshape.
I feel a real obligation to make teaching CAD and data management engineering, make it easier for educators to teach. At 2 different points in my life, I worked teaching, in one case teaching CAD, and I had been working for a few years building CAD tools. But then when I went to teach them, I was like, oh my gosh, this is so hard. The systems were hard, teaching it is hard work. I feel a real obligation to make teaching CAD and data management engineering, make it easier for educators to teach, because I know what it was like trying to teach it. And I think with Onshape, we have the new generation of tools to not only pass along better experiences to students, to teach them better, to teach them in the modern ways of work, but also to fit with the expectations that the students have coming into education these days. I mean, students would come in and look for a SaaS-based system that runs on a Chromebook or MacBook or something. They're just going to say, well, of course that's the way it will work. Of course it will be on my phone or my iPad. For our mission that I and all other engineers have to educate the future workforce, Onshape is the perfect tool to step into a new generation of doing that, to teach them even better, and that's our obligation.